this YR webinar on a really exciting topic, Liberate R Coder by Faris Naji. So first of all, I just want to apologize for the delay. I have just a technical glitch, and thank you for staying there with us. Our webinar on a really exciting topic, Liberate R Coder by Faris Naji. So here we have Faris Naji. He's a mathematician with 20 years of experience, and his work is really like on helping biologists doing the work, but not only. And he's also founder of R Tercen, which is a company helping in the code and day-to-day activities when it comes to data science and analytics. So I will leave the floor to Faris Faris, you can go ahead.
Great. Thank you, Ahmadou and Marcen. Thanks for solving the technical glitch that we had there, and I appreciate that, and inviting me. I had to take this presentation over from Marion Liboubin, who had a baby, so I'm doing the presentation instead of her. So basically my talk, and I appreciate people coming and waiting. So I will talk for the next maybe 40 minutes, since I think we lost 10 minutes there just with technical glitches. So I'll talk for 40 minutes and have 10 minutes talking or question and answers. So the title of my talk is Liberate the OR Coder, or Liberate the Coder and Empower the Non-Coder. It's all about trying to solve or bring together coders and non-coders. So a coder, and I've been in, as Ahmadou said, 20 years in this area. I'm a coder, I'm an OR coder, I love OR. I've been using it for the 20 years, especially the bioconductor packages in the bioinformatician role. And I've been working with non-coders for years, especially biologists, doctors, oncologists, medical doctors, of course. So I've done a lot of communication with non-coders, and they are the domain experts, the non-coders. They have the domain knowledge, and the coder has the ability and the tools, and has fantastic tools. So this talk is all about trying to bring these two together, the coder and the non-coder. And hopefully you will agree with my approach. I have started a company called Tercen, but it uses quite all the open source ideologies. And I think I've taken a fresh approach to this problem. So to start the issues, I mean, a coder usually produces a fantastic, cool, and useful OR package, or sometimes it's a pipeline, an OR pipeline. And the coder needs to basically, if the package is for coders, then it's okay. Then the coder can make a package and deploy it to CRAN or bioconductor, and everybody's happy. But if the package is predominantly aimed for non-coders, that's when some complexities start being introduced. First of all, the non-coder doesn't know much about how to, of course, use it, and the coder has to take care of package management, which makes sure that the packages there's dependencies are working. It has to make sure that there's a data management layer, because the non-coder usually wants to put a layer on top of the OR package or the pipeline, or wants to add extra information, usually meta information. But sometimes data management can also be the non-coder wants to be able to sub-select before giving the data to the OR package, manipulate the data just before the OR package. The coder also has to deploy the code. Deployment can be on the web, or using maybe a Shiny app, or deploy it using RStudio. If the coder decides to use RStudio, then the non-coder has to know how to start RStudio, has to know about Git. And then also the coder has to maintain the actual code and update it with bug fixes for the non-coder, and train the non-coder as well, making sure that the non-coder uses the package properly and not incorrectly. The coder has to kind of do a help desk support function to the non-coder to make sure the non-coder can quickly be deblocked. Coder has to supervise also the non-coder, and sometimes the coder will do workshops to promote the package or the pipeline to the non-coder. And this, in a lot of cases, it actually works out this, but in a lot of cases it doesn't. And I've been involved in the ones that it doesn't work out because the non-coder goes to the workshops or tries to learn OR to be able to use the OR package properly, tries to understand Git and Git versioning. And in my workshops anyway, I had maybe a 10% success rate on converting non-coders to coders. So it's non-coders basically, especially because they're domain experts, they have other things to focus on, and they don't have the time to learn programming. Not all of them. Sometimes some of them do convert, and as I said, it works very well when it does, but most of them don't. So it can introduce this disharmony between coders and non-coders. And the ideal scenario is that a coder can just work on the kernel or innovate on the algorithms and basically work on the methodologies and supervise the methodologies, and can work on educating non-coders and have very little deployment issues, and that the coder doesn't spend time becoming a help desk basically, and can focus on the real meat or the kernel of the code. And ideally the non-coder wants to get full control of the data analysis pipeline, wants to add the meta annotations, wants to visualize and interact with the data and the code and the algorithm, I would say, and handle large size. And I call this what the coder wants is a liberation, and what the non-coder wants is empowerment. And that's basically my talk. I'm not sure if people realize this, but in the labs, in the biology, in the last 20 years, there's been a revolution in the lab machines and the measurements that have been done in labs. In the classical way before 20 years, let's say before let's say at the end of the 1990s, they were designing on their experiments, and they would take a long time to run their experiment, a couple of maybe days, a couple of months on running the experiments, and they would spend relatively little time on analysis. Well, that's changed in the last 20 years. They spend more time on the analysis than before. The running is basically in a couple of hours, and the design is a little bit more because there's more factors that they can do. These machines, especially the genomic machines, the Luminex machines, the Illumina machines, the mass spec machines, are producing enormous amounts of data, and the biologists or the non-coders are spending more time doing analysis. To make matters a little bit worse is that there's not enough coders. Many non-coders, I've been in departments where there's been 30, 15 non-coders to every coder. So this doesn't help that there's just not enough coders around. And this causes a lack of harmony, but I want to bring back harmony to this problem between the coder and the non-coder. And I've started a company called Tercen with a co-founder, and I have a team now of 7, and where we basically, in the landscape, if you did a tools landscape and you put on the x-axis the small data to the left and big data to the right, and you had high coding skill on the bottom and low coding skilling on the top, you basically have 2 types of tool sets. But the Prism and the Excel is what the biologist or the non-coder is using at the moment, and it's very flexible, and it doesn't have much coding skill necessary, and it can handle small to middle size data. And then on the bottom here, which is the high flexibility and the high performance, is the or the bioconductor packages, the Python, the SAS. And there's nothing in this area, which is where I started the company, or we started now. It's called Tercen, and we think that there needs to be a tool or a platform that can handle big data with low programming skills. And the way I've done this is to put a layer on top of OR, a very flexible layer. The closest equivalent would be Spotfire and Tableau, but we are much more flexible than Spotfire and Tableau. There are other products as well, but we've taken a very fresh approach, I think, and I will give you a demo on this, how we've taken this approach. So I've taken some use cases, especially a large Excel case where a pipeline or a coder has produced a large Excel because of a pipeline or an OR package. I'm also going to show you a Shiny app case where a coder has produced a Shiny app and wants to deploy it. I also going to show you a meta annotation issue where the biologist wants to add meta annotation to the pipeline or the OR package, and also showing working in teams or groups when you have a multi-site data analysis, especially now in Corona. Everybody wants to work at home, but how do you work at home when everybody, when you need a tool that can basically spatially, that it can work across different sites. So I'm going to go to Tercen. I click on the button here, it'll just bring me over. This is Tercen. It looks very similar to GitHub, which is not a coincidence because I got inspired by GitHub. So all these concepts for GitHub are here for the non-coder. GitHub is fantastic for the coder, and I wanted to bring something for the non-coder. Here I'm in a team, it's called YR. You can create projects like in GitHub, or repositories, let's call them. You have libraries, you have members. I'm going to create a project here. I'm going to click on new project, and I'm going to do an, let's say, an online demo for YR. And I will create a project. It creates a project, and immediately when it creates it, it puts me, just like in GitHub, you are now in the repository. You can do a new data set, a new workflow, a new file. I'm going to upload a data set, and I'll show you the data set first. It's a typical bioinformatics data set, but it can be any type of data set. If you look at it, it basically has, in the first column, you have all the genes. So these are the names of genes. They look like numbers, but they're actually gene IDs. So they're identifiers. And each of these columns here are samples. And they've been measured in these machines that I mentioned in the lab. So each sample has been put in the machine and the genes have been measured. So you have here, we call this a wide format, or as people from the tidyverse would call it. And the biologists use a lot of Y formats. And now these here are the measurements of the genes, and these are the samples, and these are the gene identifiers. And I also have another file describing the samples. So for every column that you saw in the previous Excel, it has a meta annotation. So this column was the name of the column in the previous one, and you see that it's from a tissue and it's a cancer subtype. So this data set is from a cancer study from 2001 from Javed Khan, one of the first, and it was a Nature paper, so it had a high impact. It was a very famous paper. And then the last file here is how each gene, just again, it's like meta annotation. Each gene here has an identifier, and there's extra meta information about the gene, like what chromosome it came from, what symbol it has. So it's extra annotation. So you have two meta annotation files, and you have this measurement file. So if I go back to Tercen and I say new data step, I say what I need to select, like the delimited text here, and I select delimited text. I choose the file. I go to my desktop, and I take the wide format that I showed you, the first file. I go next. It basically gives you a standard type of import function where it shows you the columns that you will get. And I have an advanced tab up here for biologists or for non-coders, and they can take a wide format and they can gather it to use the Hadley or tidyverse vocabulary, or it's called pivot wide at the moment. But I can basically gather all the columns except the gene ID. So that means all these columns that I showed you in the Excel are samples, and I will call them samples. And the actual values they represent, I will call them measurements. So I'm doing basically in my upload, I'm doing a gather or a pivot wide. So I'm doing upload. So a lot of biologists wouldn't be able to do that since they would need to program. So now I have the long format version of the Han dataset here. Now I can make a new workflow. And I can make a new workflow for, let's say, my analysis. And you give it a name. And then once you create the analysis, you get this white canvas. You right click and you say add. It says, what do you want to add? I want to add a table because that's what data is called in Tercen, a table. It shows the Han wide here. It says wide, but that's just the file name. It's actually now a long format. And I say, okay, maybe I should rename it to say Han long, because in the import function it did that. Now I can start manipulating the data by clicking on it and right clicking and saying add and taking a data step. I can add other ones as well. You'll notice the joins, which I will explain later, and I can add a data step. So and it immediately opens the data step, and this is called a cross-tab view. It's inspired also by Tableau and Spotfire, but it's unique in what we've done with it. But you will see on the left here this thing called factors. This is what happened to the file when we uploaded it and I converted it to long. You have the samples, you have the measurements, and you have the gene IDs. The measurements is what the numbers were. When I grab them, you'll notice it goes green where I can drop it. And you can put it as a filter concept. You can put it as a label, color. You can put it as a row concept. You can put it as a y-axis concept. You can put it as an x-axis concept or a column concept. Here, I'll put it as a y-axis concept. So this is all the values that you saw in the Excel, all the measurements for all the samples for all the genes. And Tercen automatically ordered it with the lowest value to the left and the highest to the right. And now I can add more annotation. For example, the gene ID, I'll put that as a row because in the Excel it was the row. And here are all the measurements for each gene put into one cell. So you can see multiple points and all ordered by the lowest to the left and the highest to the right. And then you can take sample, which is the last annotation here, and I'll put it as a column concept because in the Excel, that's the way we had it as well. So this is basically the Excel done visually. So you have a single data point, just like in Excel, and you can color by the measurement and you can go into heat map mode, for example, which biologists use heat map a lot. This is the representation. This is your Excel basically projected as a heat map. Heat maps are very useful in that the redder it is the higher the number, the bluer it is, the lower the number, and green is like the middle of the scale. So these heat maps can be manipulated. We call this a projection. I will rename this data step and call it a heat map because we will come back to it. But I'm going to duplicate and show you some concepts of computation now, which are using what OR is doing and how we use OR. So here I open it again. It's the heat map. I'm not going to use the coloring. I'm just going to go into point mode. And maybe I'll actually remove the sample grouping. So this is exactly like in tidyverse when you group. Here I'm taking away the sample by or group by. So now we have all the data points for each gene in each cell. And I'm going to add an operator. And I click here and I can add the mean operator. You can see so I'm going to add it here and it's going to do a mean per cell. How do I know this? I can show you the code. If I click here on the version number, it goes to GitHub and it shows the actual code that we're using for this mean operator. And it's in OR, and you can click here, the main.or, and you can see the code that it's using. It's using the library, the Tercen library, which is the one we wrote. the library is the dplyr, and it's doing a context call, which is basically connecting to the API. And it's selecting the y-axis, the column and the rows, and it's sorting by columns and rows, and then it's calling the mean function. Now this column and the rows and the y-axis, or the column index and the row index and the y-axis, that's coming from this projection. And in this projection, if I go here to the tables, you'll see how it looks like from the API point of view, is that you have the y-axis here, which are the values, and then you have the .ci and the .ri, and they're basically representing the column index and the row index. So this is 0, 0. So all if you look here, all these, this is basically column 0, 0, and this is 0, 1, 0, 2, 3, sorry, 0, 1, 0, 2. So we are actually, each of these cells is indexed by a CI and ORI. And when you do that code that I showed you there on the GitHub, it's basically using that table, and it's doing a mean for of all the dot or the y's for each CI and ORI. And then it gives it back to Tercen. So this is what's actually being run. So if I go back to Tercen and I run it, I'm actually executing that OR code, and it's executing it for each CI ORI. It's doing a mean function, and it'll give basically a mean value per gene. That's what it'll do in this case. So now it's run. Maybe I should rename it, and I'll just call it mean by gene. And I can look at I can add a new data step. It'll automatically open it for me. And if you notice here on the left, it has the original long format that we had with the measurements, the samples, and the gene IDs, but now it has this extra factor called the mean value, and it automatically put the mean value as the y-axis here. So it's showing you the mean value of the gene, and we've used a projection with the output. And that's the concept behind Tercen, is that you can build up different computations, all calculated by R, and you can reuse them in the projection. In the case of mean here, like I could color by mean, I could actually make a heat map of the mean value itself compared to what I did, the heat map of all the individual measurements. Now this is a heat map of the mean. And the mean, I can also use it put it as a row concept here. And now I'm ordering by the mean. If I didn't do that, it would order by the gene ID, for example. So you can build up basically very sophisticated projections. But let's go back to the heat map here, and I'm going to duplicate it. I want to show you a shiny operator and how it works in this case. And in the shiny, let's do a shiny. I'll rename this and I'll call it shiny example. Oops. And I'm going to install the shiny first because on this YR is a team, and in the team there's only one operator available called the mean. So I'm going to add basically an operator, and I'm going to take it from the GitHub. So I'm going to GitHub, and I'm going to look for one of the shinies on the GitHub, and I'll just type in shiny here, and I'll take the shiny heat map. If I see it, there it is, this one. And I look at the last version, and I look at the tags to see what is the last version. It's 017. So I'm going to add the shiny operator, and I go back to Tercen. I give the URL, and I give the tag version that should be 0.1.7. That's the tag. So you can also have private repositories if you didn't. All these are public. So the heat map has been added. So I can go back to the workflow. And the quickest way is to maybe go here. This is the workflow, and I'm going to do the shiny here. I'll put this to the side because I was showing you the mean concept. I showed you the heat map. I'm showing you the shiny here. So I double click here, and I'm going to add the shiny heat map to this. So I click here, add shiny. The very minute I add shiny here, it adds this view called the operator view here. And if I click on the operator view, you actually see the shiny um, executing on the projection of this. So this is the data that the shiny is using. And this is the result here. I'm going to log the values because of the color area. I'm just going to make the height a little bit less. So this is it's a dendrogram. This is a typical type of hierarchical clustering that we do in bioinformatics. But basically here you're seeing a shiny being run on the data here. And if I want to exclude data, and I wanted to exclude a whole set of samples, which a biologist would like to do, they can exclude it from the view or from the projection here, and they go back to the shiny, and now it'll work on the modified data. So it'll be this data. It doesn't look like it, but it's actually, there's less data here. So this is what the non-coders want to do. They want to be able to give different subsections of data and filtering of data to the Shiny app. So this is a Shiny implementation. And now I'll show you another feature which non-coders like using, and it's called adding meta information. So one way of adding the meta information you can do is click on the table here and add, and you do a join. So this is like the join left and join right in Hadley's, or merging in BaseOR. It's basically can do a join. And I need to join it with a file. I don't think I uploaded that file. Let me just remember. Did I upload it? No, I didn't. So I just do a new data set. I do the same thing I did before. I don't need to do a gather because these are in long formats already. So I'm taking the sample annotation, and I'm going to say upload, and I'm going to take a new data set, and I'm going to choose a file, and I'm going to take the gene annotation. So there are two meta annotation files I'm basically uploading, and I say upload. So we have two. I can go back to my workflow. Now I go click on the canvas, I add the table, and I will use the sample annotation. And I click here to do a join. So it's going to take this table and it's going to join it to this table, and it's going to join it. You have to tell what the key is. So you have to say that the sample name in the annotation and the meta annotation is the same as the samples in the measurement table. So this will do the join. So now I have a join. I can steal or duplicate, let's say, the heat map that I did before. I can remove the link and put it after the join. And now if I double click over it, I still have the same heat map that I had before, but now I have this extra join, and I have the extra meta information. For example, what source did the sample come from? And I can grab it and I can do exactly different projections. So in this case, the source, in this case, there was two sources for these measurements. They came from tissues or cells, and also the cancer subtype, what type of cancer that it came from these samples. And here you see that there's 4 cancer subtypes spread across cells and tissues. So you can bring these in. And similarly, if I wanted to add gene information, I would then do another join. Sorry, put that over there. And I will click on the canvas, add a table, and add the gene meta information. And I'm going to connect it and do it. And I do this. I click on the join, and I can say that the gene ID in the meta information is connected to the gene ID in the measurement table. So now, and I can do a run. I can take I'll just rename this as the heat map with sample anot. I'm going to duplicate it now and take the heat map and add the gene data to this. So here we have the cells. So this is the meta information at the sample space. And now we also have it here, this extra. You see the first original table here, which is the long format. that I imported. Then you had the join, which was the sample annotation. Then you have the join here, which is the gene annotation. So these are gene IDs. So I can say which chromosomes. I can put chromosomes as a row concept here, for example. So now you have the chromosome it's from, and you can use filters just like in dplyr. For the non-programmers, they can use filters. They can filter what they want. Let's say they only want to look at chromosome 1, all the genes on chromosome 1. They just say chromosome, that factor has to equal 1. And they have a heat map only with chromosome 1. And they can maybe add a shiny to this, for example. And now they're running the shiny from the bind from the coder, and it's only working on chromosome 1 data, for example. So it allows the non-coder, or it empowers the non-coder in that they can do what they want, and it liberates the coder because the data management is being taken care of by Tercen, the deployment is being taken care of by Tercen, and the biologist or the non-coder can use to the full power all the code that the coder has created on GitHub. So I will show you a final thing here. Let's say in this project, which I've called online for YR, we've also used this concept of README files. So when you click here and you make a new file for this project and you call it readme.md, just like in GitHub, every repository has a README. Here you have it, and you can edit it, for example, and you can you can write markdown comments here. Maybe I have something, I thought I wrote something before the talk. So here, I put this in Notepad before before I started. So I'll just paste it in here since it'll, and notice it's just standard markdown syntax, but we put this dev statement in, and I show you what it does. Well, here it says deleted, but that's because I haven't put the right identifiers in. But you see the markdown, and I'm now going to find the right identifiers for this projection. I have to go back to my analysis. Let's say I wanted a heat map here with the chromosome 1. You see it has this URL up at the top. So all these views have these special URLs. And what I'm going to do here is take this URL, copy the unique part of it, go back to the README, which is in this layer here, and edit it, and then replace the right identifiers based on the view. So for example, the first hex number here, hexadecimal number, represents the unique workflow that we just did. And the second hexadecimal represents the unique data step for that heat map. Controls here, this one represents the unique data step. Oops, I can't copy paste very well. Sorry. And I paste it here. So now I've put the unique URLs and I say OK. And now it embeds the view from the workflow, and you're actually seeing a live view. So if you change anything on that view in the original, for example, if I go back to my analysis, and this is the one I took it from this URL up here. If I decide to get rid of the chromosome restriction here, which was a filter, and I go back to the README here, it just now shows you the full, it's a live view basically. And what's nice about this README is that you can work together. For non-programmers, they can start making READMEs themselves, and they can share it, and you can change the project setting to make it public, and you can share with basically with a group of people or public and work on it together. So I'm basically finished, but I'll just sum it up in 1 minute here. I've shown you the cases on Tercen, and I've shown you the cloud version, which is free, but we also have an enterprise version, which is a Docker version that you can download. We also have a Tercen version of Tercen, a studio version of Tercen for development. So you have a full development environment. It's basically RStudio and Tercen together downloaded. And I've talked about these use cases, why the non-programmer gets empowered and the coder basically gets liberated. So now I hope I convinced you that maybe I haven't solved the complete problem, but I've at least alleviated I have made it more harmonious between the coder and the non-coder. I'm looking for more use cases, so please contact me by email. I'm looking for R coders as well to make operators or to work with me. So I'm looking for those. Excuse the bad photoshopping. You can go to tercen.com and it's basically for free. And let's get going, and please sign up, and you can use my email here to contact me. So my name is Faris, and I'm open to taking questions. I'm sorry, I might have, if we have 10 more minutes, so I cut my presentation a little bit shorter because of the technical glitch, but this will.
Wow, thanks a lot. Really, really, I think it was really packed with a lot of information, and I see a lot of interesting questions. So first of all, talk and for being also mindful of your time. I think some part of us wanted also to see the rest. So maybe if it pop up in questions. So I think I will go. I think the first question was really related to your experience with bioconductor. And asking about, I think, the difference between CRAN and bioconductor, and particularly the way they release software. So
Yeah, so
just if you could,
bioconductor,
based on your experience working.
well, I was there when bioconductor started, so they had to manage versions from the very beginning, and they had a lot of interdependencies. So they built on hindsight, maybe they could have used, but CRAN was not as organized so bioconductor was more organized at the start. So yes, they have used a different, they have these dependencies between packages that they check themselves, and they have their own installer. Bioconductor has its own installer, and it checks for dependencies and it keeps things up to date. So it's a smarter type of installer. But I find that the whole OR packages, it's got way better in terms of package management, everybody. But there's still problems sometimes, and I still have issues. And that's why I think in Tercen, we use the ORenv package, and that has really helped a lot to do the package management. So we use ORenv to manage, and it can handle bioconductor packages, and it can handle CRAN packages. And when you download Tercen Studio, we have ORenv activated, and we cache all the packages on Tercen. So when a package has already been installed by someone else on Tercen, you don't need to install it from source completely. So bioconductor it had to, because of reasons of how it started, it managed its own versions, and it was a smarter version control, but there's still issues. Hopefully maybe the two communities or sub communities, because they're the same community, will synchronize. But it takes a lot of work to take all the older packages and move them over to a new versioning. I mean, but still, bioconductor is an incredible resource. They did incredible good work, and CRAN also, all these volunteers, and it's just amazing.
Yeah, thank you. I mean, a lot of it. So I think the following question is a little bit different. Looking at what you shared, your screen and the Tercen tool. So it's like, what software did you use to create the application?
Yeah, so we had to make a decision for the GUI layer. Of course, OR is our main computational language. So OR is, the mean operator, the shinies, everything is all OR. There's no custom code for us. The actual GUI that you saw was in Dart, like it's called Flutter now. But when we started with Dart, maybe 10 years ago, maybe 7, now it's called Flutter. And it's basically a JavaScript. It's a type of JavaScript, which is good for large projects because JavaScript has also moved along in 7 years, and it's taken a lot of ideas and it's moved. So it's basically JavaScript type of language, very similar. If you know JavaScript, you'll be able to write Dart. And it's very good at the web. That's why you see that smooth. We also have a indexing technology and a relational model that we use in Dart, and we use a bit of Rust and C++ for some of the, for example, transferring memory or handling the binary representations. So we use a combination of Dart, C++, Rust, and R.
Thank you, Faris.
Hmm.
The following question is about another programming language that I think also a lot of people in the bioinformatics field are using is Python. So the question is the Tercen product also available for Python users?
We nearly did it last month to put out Python. I'm an OR guy since 20 years, so I started with OR, and so the only reason I have OR at the moment is just because I was familiar. But Python, I've been asked it many times, and I will do it. Tercen's model, this indexing model, this relational algebra model that it has, and this GUI has no dependency on the language, the computational language. So we made it agnostic. So we have Tercen Studio, which is a development environment with our studio, but so we will put Python. It's a matter of time. I'm a small company, so we focus, but we're getting so many requests. So eventually, just like in the GitHub there, it can be a Python code. You'll be able to bring it in. And if you saw my mean operator, it was just a table in, table out with I used Hadley's pipelining to do the mean function. But you can, it's just a table in, table out. That could be easily a Python code to just calculate a mean per CI and RI. So the language is actually, someone has asked for a MATLAB from me. I got a MATLAB request, and I actually want to do it as well, where operators are in MATLAB.
Yeah, I'm sure you will get a lot of requests, and also I think a lot of people now are also playing with Julia.
Yeah.
So I think it might be interesting that you are agnostic by design. So that's really cool.
Yes, cool. Yeah, and Rust as well. We're keeping an eye on Rust. Rust is really performant because some of the large genomic data sets. But I think what will happen with OR is that they will have a lot of primitives written in Rust, and so Rust will come in via either the Python or route, basically.
Interesting. So I think the following up is, for example, in any project, how many people can edit at the same time?
It's unlimited. No, it's unlimited. Wow. So I put no limits on anything except space. So for the free version, you have, I think 10 gigs for if you pay 20 euros, or sorry, dollars per month, euros, 20 euros per month, you get 400 gig. And if you do the 50 euros per month, you get 1 terabyte. So it just covers my cost in terms of storage. So at the moment, it's a storage. If you use more storage, we're thinking of also, if you wanted to rent a 60 CPU, when you run let's say you're running your mean operator and you wanted to run it on a 60 gig machine with 10 cores, and your mean operator used the parallel or used multi CPU capabilities. We're thinking of how to do that as well. We know how to do it, where it shoots up when you run an operator, it'll shoot up a machine with the right number of CPUs. So we're thinking of adding that in your subscription, you can rent a machine for a 60 CPU, or not, sorry, 60 gig, 10 CPU machine for half an hour, for an hour, you run your operator. So that's a thing that we're going to do in the future. At the moment, it's hard disk orientated, but we think also that we will have a CPU ability to, if you wanted to have short-term large CPU ability for some of your OR code.
Okay, thank you. Thanks a lot. So I think we have many other questions. So let's see how much we still have time. So now I think for people mindful of reproducibility, so is there any history of action that are stored somewhere, for example, anywhere in the UI, or so
You
how do
mean
you
version?
handle, for example, someone?
Yes.
Yeah,
So
for
we,
example, like history of action taken.
yeah. So everything you do on the UI is actually recorded like a command. So it's every time you add a data step, we keep that command, and we have a version of every um, modification to the workflow. So it means that you can play back. We didn't give an interface to this versioning, so we haven't exposed it, but the model keeps every single action, and you'll be able to go back just like in GitHub, where you can go back in time. It's like time travel. You'll be able to do time travel on it, to go back to previous versions. We really think it's a cool version, and we also, a cool feature of the model. We need to expose it in the GUI. So like that workflow that you saw, how to express it is we still haven't worked out the best, if people have ideas, but it basically how to see, we'll probably use the Git concepts, with the versioning, the little tree branches and tags. Maybe it's something like this. So versioning is key for us. And the model is already doing it. We're just not expressing it through the GUI. So it's a great question, because it's something we want. We also want a bioinformatician, a coder, to be able to look at a workflow and say what changed since they last looked at it. Or because what we see is that coders want to make sure that the non-coder is not using their OR code incorrectly. And so what you want to do is you create a workflow, the coder sends it to the non-coder uses it, and then the coder can do just like a git diff command, where they see the difference between what they sent on Monday and what the biologist did on Tuesday, Wednesday, Thursday, and they can do a diff command. So it goes back to the versioning question, because that's the feature that we want to implement. We'll do it probably next year. It'll be so as people like a supervisor or a data scientist can supervise someone who may not be as good or may not know how to use the sophisticated algorithm properly.
Yeah, it looks like there's a lot of new exciting features to come. So I think people will really
Yeah,
follow closely
we
the
yeah
new features.
yes, we
So I
thought
think
about
someone
it.
asked, yeah,
Sorry,
go ahead, go ahead.
yeah, we thought about it deeply. So we've been years at this. So, but all those questions are bang on. That versioning question is a very, very key question, I think.
Thank you. So I think one also interesting question, and I think you kind of touch on this a little bit when you talk about disk-based workflow in some way. So what is the biggest size of data that you can upload?
Yeah, so at the moment we're handling quite large data. I mean, we're doing 30 million data points, no problem. But we want to go big. At the moment, most people are uploading around 1 million, 2 million. We do 1 million, 2 million very, 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 very fast. Um, uh, but I mean, the data sets I'm dealing with, but you have to wait. So it's not like what you saw me interacting there, and the speed that you saw me interacting, that goes to 1 million, 2 million. You can have that speed, that interactive speed. After 2 million, you're starting having to wait. And at 30 million, you still wait. It still handles it. But we're in the next year, we're going to compress data, and we're going to start become. We want to break the 30 million and go up to the 100 million barrier. So but it keeps moving. Every time we solve it, it moves all the time. But we have a good architecture. But at the moment, I would recommend for fast, if you want interactive thing, it's a couple of million data points. And if you're willing to wait, then you can go up to your 20 million, 30 million at the moment.
Well, so yeah, thanks. I think that's really interesting. And I think the last two questions, I will try to squeeze them into one, and it will be the last one. So I think many people are really excited about Tercen and all the product. And one thing is like how we can get access and create an account. That's the first thing. And the second is, do you provide training workshops?
Yeah, so I do workshops nearly every Friday. I just had one. Well, I'm just have one tomorrow. But it's yes, so that's why I love workshops. That's the way people learn. You just go up and you can create your account. It's just like creating a Gmail account. If you have a Gmail account, I think you just click on the button, log in with Gmail, and you. So getting into Tercen is very, very quick. Um, so it's just it's trivial. Knowing what to do in Tercen, we have some videos, we have a few markdown documents. We're creating videos now, but I am available. You send me an email, faris.naji@tercen.com. You I would be great to have a few people in the group. If there was a group, if there was only one or two, then I will do a session with them. But if you go to our YouTube channel and you go to our GitHub, you see documentation there.
Oh, thanks a lot. I mean, it was really, really interesting, and I think you receive a lot of feedback. So I
Yes,
myself,
and
I think I will try to play a little bit with it. I'm not the
yes,
informatician, but I think I really like the interface. Useful, I
yeah.
think, in some workflows. So thanks a lot for your time
Oh, I
and
appreciate
availability
that.
and being flexible because you adapted the presentation. So,
Yeah.
any
I,
last word for the YR community?
uh, I think the Y or community is fantastic. I want to thank Marcin. I think open source is fantastic. I'm capitalizing on all this. I would be nowhere without the Y or the or the Y or anybody. I would be nowhere without GitHub. So I'm putting a layer on top of all this that's missing for non-programmers. I feel that the programmers are living in Hilton. They're living in they're living in a hotel, a Hilton hotel, and the non-programmers are living on the streets a little bit. And I'm trying to fix that up. But so I want to thank the programming environment, the coders and the OR programmers, and I want them to work with me. I need that community to help me because I think we have a mutual benefit. Because I think coders, if they had more access and more ability to basically get coders to use their stuff, they would be happier people. I mean, I have get great pleasure when someone is using my code when someone is using my OR package, when someone is using my pipeline. It's the biggest honor you can have um, if someone finds it useful. And I think so. Thanks very much. Thank you, Marcin
Oh,
and Ahmadou.
no,
Thank
no,
you.
yeah, thank you. Thanks again. So, bye